Hello, good day, ladies and gentlemen. Today we have an Olympiad Math problem to solve. This problem is really cool. I can testify this problem is a little bit tough. We have here that x plus 1 over x is equal to root 3. Right over here, we are going to evaluate this expression here, x to the power of 21 minus 1 over x to the power of 21. Okay, now let's get started. We'll be making use of the following algebraic identity: a plus b raised to the power of 3. This is equal to a cubed plus b cubed plus 3ab into bracket a plus b. Right? From equation 1, we have x plus 1 over x. This is equal to root 3. Now let's go ahead and cube both sides of this equation. And here, we cube here. From the left, we'll be making use of this property here. So we're going to have the first term in the bracket cubed plus the second term in the bracket cubed, that is 1 over x cubed, plus 3 times the two terms here, that is x times 1 over x, which is 1. So we're left with just 3. Then into bracket the sum of the terms, x plus 1 over x. This is equal to, root 3 cubed will give us 3 root 3. Now do not forget that from the original problem, x plus 1 over x is equal to root 3. So we're going to substitute that here. So we get x cubed plus 1 over x cubed plus 3 root 3. This is equal to 3 root 3. Now from here, let's go ahead and subtract 3 root 3 from both sides. We get here x cubed plus 1 over x cubed. This is equal to 0. Now, by multiplying both sides by x cubed, and here by x cubed, we obtain x to the power of 6 plus x cubed times 1 over x cubed, which is 1. This is equal to 0. And from here, this implies that x to the power of 6 is equal to negative 1. But we have a problem. Remember, the expression we are trying to evaluate is x to the power of 21 minus 1 over x to the power of 21, right? But right over here, we have x to the power of 6, and we know that 6 cannot divide 21, right? Like 21 is not a multiple of 6. So what do? The only options here we have and we are looking onto is to obtain something like 3 or 7, right? So what do? Now with the property in algebra, we can rewrite this as x raised to the power of 3, then squared. And this is equal to negative 1. So from here, if you take root of both sides, we get x to the power of 3 is equal to plus or minus square root of negative 1, and that will give us plus or minus I. Wow. So we can see we have something really cool from here, because this 3 here is a factor of 21, right? Now, so far we have x to the power of 3. This is equal to, let's use the positive I. Then let's go ahead and raise both sides to the power of 7. And here to the power of 7. From here, both of these will multiply together. We have x to the power of 21. This is equal to. Now from here, let us see how we are going to simplify this imaginary unit to the power of 7. So the idea here is to make use of this property, a raised to the power of b plus c. This is equal to a raised to the power of b multiplied by a raised to the power of c. So from here, this can be written as I to the power of 6 plus 1. Then with this property, we have I to the power of 6 multiplied by just I to the power of 1, which is I. And again, let us recall that I squared is equal to negative 1. So from here, we have x to the power of 21. This is equal to I squared, then raised to the power of 3. Yes, of course, 2 times 3 is 6. Then multiply by I. And from here, we have x to the power of 21. This is equal to I squared here is negative 1. Negative 1 power 3 is negative 1, since 3 is odd. Then negative 1 times I here will give us negative I. Wow. So we have a solution for x to the power of 21 from here. Now, we have the other value for x cubed, which is negative. So from here, we have again. So from here, we have x to the power of 3 is also equal to negative I. So here, raise both sides again to the power of 7. Since we're interested in finding the value for x to the power of 21, so here we get x to the power of 21. This is equal to, this property, a times b to the power of c. This is equal to a to the power of c multiplied by b to the power of c. So from here we can write this as negative 1 times I to the power of 7, right? Then with this property, we have negative 1 to the power of 7 multiplied by I to the power of 7. So from here, negative 1 to the power of 7, since 7 is odd, is negative 1 multiplied by I to the power of 7 is negative I, since we have it here. Where is it? We simplify I to the power of 7 as negative I. So here we have a negative I. And from here we just have positive I, right? So from here we have again x to the power of 21 is also equal to I. We have the second solution from here. Now let's talk about the expression we are trying to evaluate, right? Okay. So from here, x to the power of 21 minus 1 over x to the power of 21 is going to be equal to, now with the first value for x to the power of 21, we have negative I minus 1 over negative I. So this is equal to negative I. This negative here with this negative here, we have here plus, Abby. Okay, now what of 1 over I? 1 over I, this is equal to 1 times I over I times I. And here we get, the bottom here is I squared, which is negative 1, so we have negative I, right? So here we're going to have, in brackets, a negative I. And from here, we simplify this as negative I minus I, which is negative 2I. Okay, we have the first solution for x to the power of 21 minus 1 over x to the power of 21. From here, we have to make use of the other value from here. So we have here 1 over, that is x to the power of 21 minus 1 over x to the power of 21, which is I minus 1 over I. And from here, this is I minus, 1 over I is negative I. From here, we get 2I, right? And here we have the other solution. So now we can conclude that x to the power of 21 minus 1 over x to the power of 21 is equal to, we have negative 2I and positive 2I. So combining them together, we can say plus or minus 2I. And here is the solution. Thank you for watching. Please, if you really enjoyed this video, kindly subscribe to my channel. Also like, comment, and share. Bye-bye.